Welcome to the Curing Cancer Using a Modular Approach to Ensure the Safe and Repeatable Production of Medicine. It was the presentation that Duncan and I gave at NI Week 2015. Unfortunately, the recording didn't work at the time, and we're doing it again. My name is Fabiola de la Cueva. I'm a software architect and partner at Delacour, and I'll let Duncan introduce himself in a little bit. At Delacour, we work with companies that already have teams of LabVIEW developers, and then you realize that they're actually doing software and they need to learn about software engineering practices. We teach them how to do source code control, how to organize their projects, how to expedite their LabVIEW development. And we are based in North America. There's Luis Orozco and myself, and in Europe we have Chris Roebuck. We are also experts in teststand, RF, and LabVIEW in general. So some of the services that we provide, like I mentioned, is do the architecture for yourself. If you don't have an architect in your team, we can also help you with implementation. We can help you on automated test strategy and process optimization. And we do best practices training and implementation. There's a side of the house. Luis is in charge of the hardware design. We can help you to do test fixtures as well as doing instrumentation. So if you need a compact RIO module that does something specific that is not available on the NI catalog, we could, for example, do something like that for you. And we also work on test data management. All right, Duncan, so I'm going to introduce yourself.
Okay, hi. My name is Duncan. I think of myself as being extremely unique out of all the speakers that you've heard at NI Week. My contribution to the talk has to do with my ignorance of LabVIEW. I'm speaking from a project manager or an end user viewpoint. I am the grouchy guy who approves the money. But anyway, nobody's completely worthless. Some can serve as a bad example. So before we get to that part, which Fabiola has been eagerly awaiting for, let me tell you what my normal job is. My job is to implement continuous improvement projects for PerkinElmer, usually through automation that will make for faster, better, safer, and cheaper products. About 5 years ago, our lead LabVIEW programmer left us in the middle of a fairly complex project. I asked around and I tried out a few programmers, and we ended up with Fabiola. She was the only programmer who didn't blink at the object-oriented programming or the undocumented spaghetti code or my unrealistic expectations. I was warned, watch it, she's expensive. And anyhow, so this is PerkinElmer in Boston. We primarily produce chemical reagents for pharmaceutical, biotech, and government-funded research institutions. In addition to research compounds, we also manufacture what are called radiotherapeutic nuclides. Some of our products are radioactive. Radioactivity is often used to diagnose where a chemical or drug ends up in the body. For example, cortisone can be made radioactive, and with proper scanning equipment, one can determine exactly where it ends up, like in the liver or the brain or the hypothalamus. Very small amounts of radioactivity are highly detectable using PerkinElmer's radio detection equipment. Most of the drugs that you see in a drugstore nowadays have been tested with these products. In addition, very small amounts of radioactive material can be attached to highly specialized proteins or monoclonal antibodies to create potential smart drugs, which specifically target a number of cancers. This method has the potential to dramatically increase the likelihood that the patient will survive, since invasive surgery or chemotherapy or external radiation is avoided. Okay, so let's talk about LabVIEW and programming. I have a story. Okay, so here's the end user. And he's got this super complicated idea of what he wants to see programmed. Okay, now imagine for a minute that you are the developer and you have the amazing ability to fully understand the needs of an end user. Now, I'm not talking about simple average understanding. I'm talking a full understanding. Three-dimensional holographic images of the problem are in your head. You have full comprehension of the history of the problems that resulted in you being called in. You have full access to the understanding of the budget. You have full comprehension of all the personalities involved. You have full access to the future needs. You have full access to the competence levels of all the users. If only this were true. And here's an example of what I've experienced. Okay, it's easy, right? Okay, here's the end user. He wants to see the temperature of a thermocouple. Note that the NQ in the event structure of the while loop. Note the excellent and descriptive artwork of Fabiola. By the way, that's beautiful. Okay, now the project manager, that's me. I just popped up there. I'm DQing to the call consultant case structure, thinking of the budget and the time required to stop. That's wired to the stop function. Okay, now here's the super CLA. The architect is happy. Note the cape. The super architect is sharing the same idea as the end user. All is easy, right? Okay, see the easy. How many times have I said, this is me, this is a straightforward process. This is a 5-minute job. We're only talking a simple analog signal. If you hear those words, sound the alarms. Don't let this happen to you. Well, it never sounds that tough at the beginning of a project. Let me continue the story. So here's the end user. Now he gets an idea from somewhere, and this is a good thing. Can we log the temperature to Excel? Easy, right? Sure, we've done that before. There's the super CLA architect. Easy. It looks easy and straightforward. Everybody's looking like a hero. We're talking bonuses, stock options, all the way around. Okay, and looks like we get another idea here. Oh, I forgot to mention, we need 10 more temperatures. Oh, there's a pressure sensor too. Oh, we need an alarm sent via email when the stations are out of spec. Oh, who's going to control this? Oh, can we install this on different sites? Oh, by the way, the dialogues don't make any sense. Can you change the wording? Oh, this process isn't quite as precise as we expected. We need to change the hardware. Okay. Anyway, at this point, what should the developer do? What should the project manager do? The guy is saying, the end user is saying, oh, wait, we said this is a straightforward process and the budget is gone. It's long gone. How come you backed out of the agreement? You've left me in the lurch. There's the architect note, the cape is gone. I'm going to have to rewrite the software. Your hardware is inadequate. Do you have budget? Anyway, what's the problem here? Well, anyway, the programmer must take responsibility at the start of the process to fully define the project, working in harmony with the end user, and this may be very hard to do. When I first began to do these projects, I fought with Fabiola. Let's just fix the problem, or let's get the programming done so we can run the apparatus. Now, I have a short attention span. I want to see the thing work. We can handle whatever the additional needs come up as they come along, right? Now, Fabiola has been bugging me for flowcharts, and I'm pushing back very hard. Actually, the last programmer we had never did anything like that, ever. Okay, we just made the program do what it had to do. It was easy. Anyway, once the redos and the do-overs and more redos and more, oh, I forgot to tell you. And, oh, we need this or we need that. And, oh, I just heard all the stations need to operate at once. This happened to me about 100 times, okay? I gradually got the idea that maybe we need to do more work up front. Now, as I said, this is very hard on the programming if they know that the redos are coming. But the guy paying the bill is not willing to do that. And if you're expecting the project manager to be humble and to take everything that the programmer says as fact, you are in for a long life. That's not going to happen. So it's easy to insist as you start off on a project that you need to be organized. The hard part is making it work with the personalities involved. The impossible part is knowing everything that's going to be needed. How did you get there? Now, relationships are key. Now, did I say that enough or with enough emphasis? You nerdy engineers and programmer types, you have to work in harmony with the key personalities. You must find ways to do that. At some point, you got to start the project, make some graphs appear, make some motors run, make some printers print, or else the team is going to get nervous. Now, I said I have a short attention span, but I'm from a manufacturing world where I'm fixing equipment every single day. Managers tend to get very nervous when you spend a lot of time in the planning stage. Showing workable code at an early point in the development process can dramatically increase the understanding necessary for real progress. Having code that can tolerate change and tweaks is critical. Okay, you'll know exactly what you need only when you complete the project, and sometimes later. But if you want to save a lot of money and not have a lot of arguments and save time, insist on very clear and detailed, anally detailed flowcharts. But you have to balance that with testing that shows the end user where you're at and where he can go. Now, he's not going to know what the software can do unless you work with him, so you both can develop a new and better understanding of what he needs. Now, my passion is all about gaining understanding. Now, I urge you to embrace the fuzzy project end state by daring to get all the details ironed out. Now, I'm going to turn you over to Fabiola. Prepare yourself for an intense and wild ride through code that's custom made for tweaking, additions, and last-minute changes.
All right, so Duncan puts there at the end of his slide that the DQMH may be the answer. So one of the things that we have realized after years of working together are a couple of lessons learned. So the first one is we need to understand the end goal and in-between milestones. I crossed out gather requirements. When I started doing work as Labia consultant, this was something that everybody drove home. You need to gather the requirements. You have to have a very detailed document. The problem with doing that is people would get anxious, like Duncan was saying, because they wouldn't see things moving soon enough. And the other thing that I found out is that even the project managers, the end users, they don't really know what they want until they actually start seeing some movement. So having an understanding of what the end goal is and what are the in-between milestones is better. Sometimes it's okay to just give the testers, like we Duncan, one of the things that we did at the beginning is we would do simulations for the hardware and individual testers for every section of the hardware. So we had motors, we had a small VI that all it did was testing the communication with the motors and that they were moving to where they needed to move. And it was really interesting how the rest of the team actually saw that to be beneficial. When they started assembling things, they could use our small testers to make sure that things were working. So having an understanding of what is the end goal and what are the in-between milestones, I think is more important than just gathering requirements blindly. We create testers for individual parts and simulators. These would drive Duncan crazy sometimes because he's like, why are we wasting time on working on simulators? However, the equipment was going to end up being in a facility that was going to be hard for us to access with no internet access. So having simulation available means that we can make progress on some of the program tasks and test them in simulation. And then when he has access to the equipment, then do the actual verification that it actually works with hardware. So a lot of people will do simulators when we need them. I advise you to start doing the simulators from the beginning. It also helps you focus on the flow of the program, on what is it that you think you want to do before you're actually having the hardware connected. Design, model, define modules. This is what Duncan was talking about. It was really funny. One of the first projects we worked together, I wanted to do some modeling, and Duncan was like, "No, let's get to work." And I was like, but we need to have at least a general understanding of what the flow of the program was. And he just refused to do that. So I said, okay, we're going to do it your way, but there's going to be two things that I'm going to ask you. One is that it's okay with you that I'm going to be using an architecture that's going to be seeming a little bit over-engineered for you, but that I know is going to help me address the changes and requirements that I know are going to come. And the second is that you let me tell you, I told you so, anytime that we get into a corner that we could have prevented if we had done some planning ahead of time. So I guess I must have said, I told you so enough times that the next time he called me for a new project, he sent me an email saying, there's a new project. Oh, and by the way, find the initial flowcharts attached. So I guess that was driven home.
Detailed flowcharts.
Yeah, detailed flowcharts. Create modules for independent sections of the app with their API testers. You're going to see if you've seen the Delacour QMH or you see later the DQMH on the demos, that we have created modules for independent sections, and each independent section has its own tester. This allows you to be able, when problems arise, to be able to go directly to that section of code and remove everything else. If you have to run the entire code in order to test the printer, something is wrong. You should have an API tester that lets you just test the communication with the printer.
Actual example.
Yeah, there's a program that Duncan has to call me every year or so when that printer goes down and it needs to be replaced, because we need to make it work again. And what we end up doing is having to run the entire thing with water on the vials and everything, just so we can get to the point where we print a label. And that's believe me, that's not something you want to be doing. And the last thing is we need to build early and build often. In the example that we're going to show you in a minute, we were using communication with a file. The LabVIEW handles paths differently in the development environment than when you're in runtime. So you need to test that early on. If you're going to be doing something more complex that has plugins or that has a factory pattern that loads classes, all those things are going to behave differently in the development environment that they behave in the executables. As LabVIEW developers, we've spoiled because we just press that arrow key and we get results immediately, that we forget that we do have to build early and build often. So I recommend that you make sure you do that. On the other hand, what these did to us too was that we were able to deliver intermediate releases to the team that was in the process of defining the process while we were working on new features. So understanding the end goal, ask questions. One of the things that I've learned is that my role as an architect is to ask questions and help the customer realize what is it that they want. It was really when we were working on the flowcharts, it was the questions that I was asking Duncan that then he would ask to the end user that we realized, oh, okay, we hadn't thought about this. And the more questions you ask, the more you're going to be helping getting to the end, to that end goal. The other thing is the type of questions that you're going to be asking is, what are we trying to do? Why are we doing it? This is very important. Sometimes I have an example of a customer that called me once to do a code audit. They had really old code. They were going to be upgrading from, I believe it was Windows 95 and LabVIEW 4 all the way to Windows XP and LabVIEW 2009. And the code was written all with globals. I was horrified when I saw it. However, the code was working. One of the things the customer asked me at that point was to quote how much it would cost to revamp the application to bring it, to 2009 standards and move away from those globals. And I started asking questions, and some of the questions that I asked was, how long has the program been running? And they were like, well, more than 10 years. So why is it that you're doing the upgrade? Well, because the computer is starting to make weird noises, so we know that, we see the writing on the wall. And I'm like, do you need to add any new features? And they said no. And the hardware was going to be working with the new version. So as much as I, would like to have these new projects, the reality is the answer there was No, there's no need to change it. You don't have any race conditions. The globals were actually written as write once, read many, and the application works. So why do it? Why spend all the time and money on refactoring code that I cannot guarantee is going to be working the same? So I ended up not doing that project, but I had a customer for life. They keep calling me for other stuff. Where does LabVIEW part fall in the great scheme of the project? For Duncan's project, LabVIEW is just a tool. It is very, I mean, it could be C, it could be Pascal, it could be whatever. The end user, Duncan's code doesn't care. So it's important for us to understand that. For me, LabVIEW is what I eat and breathe and do every day. So it obviously to me is going to be the most important thing. But if in the project that I'm working on is just seen as a tool, I need to understand that as well.
Yeah, I'm going to interrupt. I'm going to say this: understanding the end goal and working with the architect in our case was fabulous. I mean, it actually moved the success likelihood of our project much farther ahead than it would have been without that. And I don't know that because you have to get so granular on programming, it was wonderful. And I don't know that you could be a good architect or programmer without getting that, without asking all these questions, without this level of comprehension. I just want to throw that in. I'm nodding my head vigorously on it.
And then the end user might be fine running manual tests with the tester, so don't wait to give a final solution. This is something that I struggle when I hire new people to work on Delacour projects, because they want to give me the final thing, all, you know, iron out without the kinks and the rough edges. The problem when you do that is the customer then is going to tell you, thank you, you deliver what I asked for, but it's not what I needed. So sometimes, and this is very important, sometimes it's important to tell the customer, look, I'm going to be giving you something, and we did this in this project, right, Duncan, where we gave something to the chemist, and we told them, by the way, don't put real glass vials on any of the equipment because we haven't put any of the safeties on. But if you want to start moving the motors and seeing how the sequence of that's going to work, you can start doing that. And it turned out that they were very grateful for having that option, and that also helps them tell us, you know, you need to reduce the speeds or you need to change some of the sequence of events. So it's important, as long as both sides are on the understanding that you're not delivering them, you know, a final code, you're just giving them one of the intermediate releases so they can start giving you feedback. And one of the examples that I give is like we get to work with a lot of startups that have done, you know, a proof of concept, that they had a single LabVIEW developer, and now that they're moving into production and they have a larger team, they need to change things. And most of the times they're not going to have a list of requirements, but I can ask them, give me your demo script. What is it that you want to show at the next venture capitalist meeting? And that's what we work on to be the next intermediate release. With Duncan, we would say, okay, when is the next meeting you have with the shareholders, and what is it that you want to show at that meeting? And we would focus on that. And then the final thing is passionately listen, which is something that is really hard for me, but it's very important to listen. Every time you're asking these questions, listen for the answer, try to assimilate it, and then ask further questions. All right, so create testers and simulators. This is just work at the driver level first. Do the testers for the instruments individually. So a good example is we had motors here. So the first thing we did was to do the go home, go to position, and stop, and then save those testers. And again, at the beginning, Duncan was like, you know, we're wasting time with this, but we use those testers so much and the simulators so much. And anytime a new position was added, the very first thing we would do is before trying it with the entire program, we would make sure that the tester worked. All right, design, define modules and model. So here's where I had to go a little bit. English is my second language, and I had to go a little bit into researching what model meant. In Spanish, we use a different word for a 3D model, like what an architect, what a house architect would do. They, the little 3D models where they show you the people going into the doors and how the doors are going to open and all that. We call that is a maqueta in Spanish. So it's a different word. It's not model. And then, what you're drawing as a flowchart, that is called modelo, which is a similar word. But the reason why it was important for me to realize that the word model in English was used for so many things is that it helped me arrive to this definition. It's a simplified representation. It describes behavior and it describes interactions with the outside world and within the system itself. Having a model, and this can be, a rough napkin drawing that just shows bubbles of the different parts of your system, it's very important before you start writing code. LabVIEW is really easy to getting feedback when you start writing code, that sometimes we're tempted to go directly to the code. But it's important to have these 20,000 view of what is it that our application is going to be doing. So the case study that we're presenting, we needed to automate the process to produce medicine to cure cancer. The process here was sequential. The process needed to be repeatable. We needed an operator signature and an acknowledgement was required. This was very hard for me to code in. That meant we have pop-up dialog boxes. And if you've seen any of my other presentations, you know that I hate them. However, here it was an FDA requirement to have some acknowledgement from the operator before going to the next step. And the process was being defined as we were writing the code. This was one of the hardest things because even when I had all the answers to what is it that we were trying to do, the chemists were still trying to figure out what those sequences were going to be. So the initial flowchart, detailed flowchart that Duncan sent me had, one box going into another, and then he started every week. He would send me new updates because, like I said, the process was getting redefined. And oh, by the way, now we have these other steps. And the thing that we saw is that it was very sequential, but we got to a point where Duncan said, well, it just looks like we just need to do a simple state machine. And I was a little skeptical. I was like, well, let's try something different before we go into a state machine, because I could see in my head that if we went to a state machine, we were going to end up with a case structure with 500 cases. So I suggested to list all the steps in Excel. We number the steps. We put what was that dialog box that it was going to show up to the operator. And then where is it that the different motors needed to move to? And once we listed that, we said, okay, this gives us the definition of each one of those 500 or however many cases we ended up having. But we realized that, yeah, sure enough, the rows were more than 400 rows. I did not want to code a case structure that had 400 cases because that was going to be a nightmare to maintain. And anytime the chemists would change their mind, that meant we were going to have to go to the code. But if we transpose the spreadsheet, now you have 5 steps that are repeated 400 times. Doing a state machine of 5 steps, that's feasible. And that's maintainable, it's easy to read, all the things that I love in code. So this was our Eureka moment, right? This is every step was doing a variation of those columns. Transposing the table results in calling the same state machine 400 times. And it's a lot simpler to model, it's simpler to program, and it's simpler to maintain. The other thing, too, is the end user could make minor changes without the developers getting involved. So the look of the state machine, and I'm simplifying this, of course, we had a lot more columns than those, but just in a general, high-level view, our state machine would initialize, would decide if there was a dialog to be displayed to the operator or not. If the dialog needed to be displayed, then we would display the instructions. If there was no dialog needed, we would move directly to check if the column needed to be moved. And then from moving the column, we would check if the pipette would need to be moved. Obviously, one of the options we had was no movement at all. Then we would go to the syringe, the other syringe, and then we were done. And this was specified at every row on the Excel spreadsheet. Now, one of the things that I like to highlight, I never intended Excel to be a modeling tool. However, that's what it ended up converting itself to. I never intended Excel to be the scripting of our application, but that's what it converted itself to. So sometimes just trying to find ways to describe how the application is going to work might open a new opportunity for your architecture. All right, so the other thing that we did was creating modules for the different application sections. In this case, we created 3 DQMH modules. We had a graphic user interface, the control interface, and then the login interface. We decided to use communication using user events. That's basically what the DQMH uses. And what it would be an example of the events that we were using is the GUI would tell the control module to execute the steps. The control module would broadcast its progress. The control module will tell the login module when to create the log and when to log each row. And then the user interface would tell the login and the control when to complete the application. The control DQMH is the one that ends up calling the state machine 400 times. And the Excel file with the 400 steps got parsed inside the control into a state machine object that was just basically, creating the state machine that I showed you earlier. This is also to show that there's not a single way or a single solution on how to model your software. Right here, we have used 2 models so far, a state chart for the state machine, these little bubbles with arrows, with communication arrows for the application itself, and then there was also a sequence diagram. So the sequence diagram is another UML diagram, and what we're showing here is the GUI is sending the event to the control to start the process, and it sends as an argument which Excel script to use. The control module then parses the Excel spreadsheet and queues the state machine steps, tells the login module to create the log, and sends the name as an argument, and then it starts executing the state machine. Every time it executes the state machine, it reports the progress with the name of which stage has been done. The user interface updates the progress, and at the end of each execution, we log the row. Now, this is done in a loop. Normally, on a sequence diagram, I would show a box going around this section of the sequence, but for PowerPoint, it makes it easier not to show that. Once the last stage is done, then the graphical user interface tells the control to stop and the login to stop. So that was, so far 3 different ways of modeling, as well as the, 4 if we include the flowchart itself as well, and the Excel diagram would be the third one. All right, so let's see how this video works here. If it doesn't work, when I'm editing the video, I'll insert it in here. So let me mute it. Okay, so here we go. So this demo is going back to the idea of building early and often. And what I'm going to be showing you here is that the Delacour QMH, if you can download it for free from the LabVIEWTools network. Once you download it, it's going to add in your Create project the option of creating a Delacour QMH project. And you can give it, a name, where you want to save it, and whether you want to include the do something events or not. When I'm teaching the DQMH, I normally include them just to have something in there, but in this case, we're not including them. It will add the documentation, it would add 2 testers and 2 types of module, a singleton and a clonable, as well as a top-level application. And the top-level application just calls the different modules. And it comes also with a builder specification. So right out of the bat, you can build an executable. So the reason I'm showing this is because when you start from a template, you will have those things already there. So there's no excuse to building since the beginning. We even have a version number for your executable, and you can start, working with the different modules. Now, the version number has saved us a lot of time, right, Duncan, with some of the previous applications, because sometimes it's like the operator reports an error, and we're like, we're pretty sure we solved that. So just seeing the version tells us that, oh, they have an old version, we need to go and update. So the version, even if if you don't use the DQMH for anything else, if you want to use the version information, the code is there, so you can install the DQMH and just copy that piece of code if that's all you like of this entire presentation. We're showing there that the application itself doesn't need to be a DQMH module. It can be a state machine. In this case, it's just a simple state machine. All right, so that's the building early and often. So the next demo, I'm going to show the 3 DQMH modules that we created for Duncan's module. It was the GUI, login, and control. Again, we're going to be communicating using user events to tell the GUI, tell the control to execute steps, the control to report its progress, and the control to communicate with the login module. The section of the demo that I'm about to show you is going to be implementing the 2 modules, the control and the login, and it's going to be sending the messages from the control module to the login module. I'm also going to be showing some of the scripting tools that the DQMH includes to make your work a lot easier. So what we're showing here is we already have the project created, the same that I showed you earlier. Now I'm going to go to the module tools, Delacour, DQMH, and we're going to say to add a new DQMH module. In this case, it's going to be the login module, the first one that we're going to be adding. I'm editing the icon, and magic of cooking show there. I went a little fast, but we created the icon, and that added the login DQMH module. And it adds its tester as well. So one of the things that I mentioned is that we want to have testers since the beginning so you can start testing your modules. The nice thing about starting from a template in this particular case is that I can do debugging, I can start the module, I can close the module. All of that is already given and created for me. I don't have to create any of that. Now I can move directly into creating the events I need. So I went to the menu, chose Delacour, create new DQMH event, selected the login module, decided that what I needed to do was a request. The name is create file. I added a description for the VI, and I'm now adding the arguments. So the things that I'm going to give it, it's what's the name and what's the path or the directory where the login files are going to be saved. So, and we're going to be putting the title if you wanted to add any header to the file. So I'm going to say, okay. What the Delacour scripting tools are doing is they added to the project the calls that I needed, and it created the request create file, and it added the description that I added on my arguments window, and now I have there my create file. So I did there control space for quick drop, control D to create all the controls I needed. And now I'm just arranging there on the tester. So we are going to do that. I also want you to notice when we get back to the block diagram that we added descriptions. There's a little blue box that tells you what is it that you need to do. So we are creating here the create file button. And we are going to be now following the description there. On the blue box, it says code needed. Assign this event frame to a new front panel control used to test the create file request event, and then delete this label when done. So I'm editing the events, and then I'm checking the create file button that I just added. And I can now just clean up a little bit so I don't get frustrated with crooked wires. So now that everything is arranged, now I have to go to the module itself that has a broken arrow, and it's telling me again the instructions. Configure these event frames for the create file event, and it's listed there among the login request events. So that was done automatically for me. And now I just need to wire from the event node at the left the different arguments. And you can see that that's listed also in the instructions: file name, directory path, and title. The create file message in the case structure was created for me, and I'm doing some cooking magic there. Cooking show, I finished and added the code that is actually going to be creating the file, and I'm just going to be adding to the local data of my module the ref number. And all of these steps for this demo are available in YouTube. I'm going to give you a link to the channel so you can slow me down and look step by step and doing it if you want at your leisure. Follow all the steps that we're following there. So now we're just going to bring back the log ref num so we can have it there in case we need to use it later, which in our case, we need to make sure that when we exit the login module, we actually close the file. So there we go. So let's try it out. So I'm going to run, start the module, show the module panel. You can see that the path is empty. I'm going to select on the temp folder that's going to be the directory. And you're going to see that I forgot there to change the browsing of the control. So I need to stop it. I'm going to go to the browse options and tell it that it's okay for me to open folders, new or existing. So that's going to make it work now. So start module, show module, go to the directory path. I can say current directory. We're going to give it a name. So this is going to be log report, and it's going to be a TXT, and I'm giving it a title. So my first log, and we're going to create the file. So you can see like magic, the event got fired and it got handled by the login module. Okay, and if we go to the C file to temp, we can see that the log report TXT was created there. And it does have the my first log added to it. So we're done. We can now just stop by closing the front panel. Now we're going to add the new DQMH event. So we had said that we were going to add the request to log, to create a log and to log one row. So I'm putting there the information and the arguments. I did not select which modules. I need to go to step 1 and select the login module. And that's going to add again into my project the place where I can test that this works. So I'm just using Control Space, Control D to add all the controls I need. And we added a new button that we're going to be using here. So I'm going to edit the event handle to use the log row button that I just created. That makes turns my arrow into a running arrow. And now I have to go to main. And again, I have my instructions there to edit the events handled by this and select the log one row that I just created. I need to now wire from the data node the data that I need, and they're all labeled there, so I know what I need to load at each point. And the log one row case was already created for me, and I just added with magic the code that I'm going to be using to log one row, and I'm going to go to the exit row and make sure that I'm closing the reference so I don't leave the file open. If you were using, communication with serial device, for example, this would be very important, right? So I'm just going to add an input there and have my errors there. One of the other things that the DQMH does is it has error reporting already in there, a simple error reporting. You can see on the front panel, there's an option. All right, so I have my format into file, and I'm going to be formatting into file the timestamp, the operator, the temperature, and the comment. So I'm going to put an indicator there just so I can see that I'm in fact receiving the data that I'm sending. I'm going to remove some of my comments there. And that will give me the latest row. All right, so let's make that look pretty and let's try it out. Now I can tell you ahead of time that I'm going to make a little mistake there. So I'm going to start the module, I'm going to show the module, and I am going to put the file that I want to create. So I'm going to do the current folder. This is going to be log report 2.txt, and I'm going to give it a title. Now I'm going to put what is it, the first row. Now you can see that I forgot to press the create file button. So I'm moving directly into creating the first row and adding comments. And when I click the log row, I get the log row there, but the log file path is not log report 2. And I get an error reported back to the tester that said I had a problem. So I'm going to try to go troubleshoot and see what's happening. So I'm going to check that the error, in fact, happened when I was formatting into string. And so I need to see where the problem is. So what I finally going to realize is that I forgot to press the create file. So I'm going to go check if the file was created at all, and I can see on the folder that it's not created. So I forgot to press the create file. But I wanted to show you that the DQMH has the debugging already in it, where I was able to show the block diagram and do the probing, and I had a nice descripting error report telling me what happened. So once I create the file, now I'm able to log row. So let's do that. What we're going to do, change it so we can see that this is the second row. Let's say log row, and then I'm going to go to the file itself, and sure enough, there it is. So that worked. So again, the idea of the DQMH is that you have the framework that already does the handling of different windows and provides the testers and does all the programming for you for the events. And all you have to do is do your modeling ahead of time to figure out what those events need to be. All right, let's see. So the last part is to add that to our application itself. So we're going to go to main. Well, like what I did there is I got rid of the singleton and Conable, and I created the other module, which was the control. I did it the same way, going to tools, Delacour, DQMH, create new DQMH module. It created the tester for me, and then I added the current temperature and the comments. And you can see that I'm getting error reporters because it says that the login module is not running. So my error reporting is working here. So what we're going to do is now integrate it with the login module. So the tester just gives me a way to know that the functions that I created are going to work, and now I can just add those functions to the application itself. So when I press the start button, what I do is I start the module, and that will start the monitoring. And then when I get and at the initialization of the application, I had already run the other modules. So I have both modules running there. All right, so what we're going to do is we're going to get also our lights are going to turn on when the modules broadcast that the login module did init. And at that point, I'm going to create the demo with a timestamp name on the C10 folder. And again, I'm using the two VIs that we created earlier, the create file, and then there's the stop modules. And we're going to run it and make sure that this works. When the control module says that it init, I'm sending the message to show the panel. So it shows automatically as soon as I say start monitoring, and everything is running, and I have multiple temperatures there. I'm going to change the comment just to show that the logging gets changed. And that'll be it. So we stop the application, and we can now go to the C10 folder and see that, in fact, the timestamp file was created, and it has the different comments. All right. So now that we have the application done, remember we said build early, build often, we can go ahead and build the executable for that. So we're going to go to application, build, and when it's done, we're going to run it and go to explore, and we're going to run the executable itself. We have a version information, and it's 0.002 because 0.1 was the very first time that I read it. And I'm going to change the comments there just so you can see that I have a new file there, and it's working. So if I open, that was the previous one that I had already done, and then this is the one that we just created. So the executable works as well as the application itself. And we'll just change the comments there just so you can see that it is a live demo of EXE. And we're going to stop the application and go back to temp. And sure enough, there it is. And there's a live demo of EXE. So again, this demos are available as separate YouTube videos if you want to, slow it down and inspect step by step. All right, so the next part is, if you want to learn more, there was another presentation also that has to do with DQMH and test stand. We'll put the link on the comments of these videos so you can go check it out. There's a recording of that one as well. The DQMH toolkit is free. What we show you is free. You can find out more at Delacour.com. We also have a blog that's called Walking the Wires, where we post things about DQMH and good programming practices and how to be successful on your Labio development. The DQMH inspiration was from Justin Gore's public and private events presentation. He did that on 2011. So it uses the JKI state machine and it uses the events, but we did some changing on the nomenclature of the events, and we added all the tools that we showed you that help you create all those events. Like I said, the DQMH is available on the Labio tools, and you can see more videos at bit.ly Delacour QMH. So thank you. Duncan, is there anything else you want to add?
No, I'm all set. It's been the project we work on was wonderful, and it continues to run flawlessly, and the chemists have been able to make a lot of changes without any assistance from me or you, which is pretty darn good.
Yeah, thank you. All right. Well, if you guys have any questions, reach us via Delacour or our YouTube channel. Thank you, and talk to you later.
Okay, thanks.
Let's stop the recording.